This is the last stop in our tour of the solar system. We're now out even beyond Neptune. You might have expected this last section to focus on Pluto. Well, it won't for several reasons. Number one, we don't know much about Pluto. Our best photographs are only as good as this. This is Pluto and its moon. So that's the first reason. The second is that, as you might have heard, many astronomers no longer consider Pluto to be a planet. We've discovered that there are other similar objects out there in the same neighborhood. One that was recently discovered is even believed to be slightly bigger than Pluto. So Pluto doesn't look so unique anymore, and it's now being recognized as just one among many objects out there beyond Neptune. Since they're beyond Neptune, we call these trans-Neptunian objects, or TNOs for short. TNOs are much farther away from us than anything else in our solar system. If you were standing on one of them, our sun would be so far away, it would appear to be just a bright star. Yet even these tiny chunks of rock and ice, so far away from us, have something to say about creation and evolution. First of all, where did TNOs come from? Supposedly, TNOs are the leftovers from that big cloud of gas and dust that evolutionists believe in. They're asteroids that never formed into planets. That would make them billions of years old, right? Well, evolution runs into problems already, because the more we learn about TNOs, the less they look like they're billions of years old. Scientists have recently discovered that many of the TNOs have fresh ice on them. The material apparently came from volcanic eruptions. But if these little rocks were really billions of years old, they wouldn't be geologically active anymore. They don't have any sources of internal heat, and they certainly don't get much from the sun. The temperatures out there are about 370 degrees below zero. So if they really were billions of years old, they would have frozen solid eons ago. They wouldn't have any volcanoes left anymore. But apparently they do have volcanoes. Apparently, they're not billions of years old after all. But that's not the only evidence for a young creation that TNOs and other objects give us. Let's talk about a group of objects that are among the most spectacular in all the universe. Comets. When a large comet appears in the sky, it can be a breathtaking sight. But what are these objects? Comets are usually described as big dirty snowballs flying through space. During most of its orbit, a comet doesn't look very exciting. But when it gets close enough to the sun, it heats up, and the ices begin to sublimate into gas. The gas streams out beyond the comet as it flies through space, forming the beautiful tail that we see from Earth. But there's more here than just beauty. A comet burns up and loses material each time it passes by the sun. It gets smaller and smaller each time. Eventually, it will be so small that it will break up into fragments. We've actually seen this process happen with several dozen comets now. Comets can also be destroyed by crashing into the sun or a planet. For example, we saw the Shoemaker-Levy comet break up and hit Jupiter a few years ago. The marks you see here on Jupiter were caused by the comet's fragments smashing into the planet. Comets can even be thrown out of the solar system completely, thanks to gravitational interaction with other objects. So when you see a comet, remember that it's beautiful, but it's also temporary. This has caused a real challenge for evolutionary models. We see lots of comets today, but they can't have been there for billions of years. Comets can't last that long. Evolutionists are stuck here. Their models say that new comets haven't been formed since the early history of the solar system, billions of years ago. At the same time, they need a supply of new comets to replace the ones that are constantly being destroyed. To solve this problem, they believe that there are billions of comets, or comet nuclei as they're called, that are left over from the formation of the solar system. These nuclei orbit the sun at vast distances away. They've never been heated up by the sun at all. They've stayed cold and frozen for billions of years. It's only once in a while that something will happen, a star passing by our solar system, for example. The star disturbs one or more of the comet nuclei and nudges them into orbits closer to the sun. At that point, they turn into normal comets with shortened lifespans. So where are all these nuclei? Evolutionists believe that they're in two different places, the Oort cloud and the Kuiper belt. Evolutionary models need both of these sources to explain comets, and recent discoveries have disproved both of them. We'll start with the so-called Oort cloud, named after the astronomer who first invented this idea. He figured that there must be a huge cloud of comet nuclei way out in a large sphere-shaped cloud surrounding the solar system. The Oort cloud has three major problems. Number one, it's never been seen. As the late astronomer Carl Sagan wrote, Many scientific papers are written each year about the Oort cloud, its properties, its origin, its evolution. Yet there is not yet a shred of direct observational evidence for its existence. Why hasn't anybody ever seen it? Because according to evolutionary models, it's impossible to see it or measure it, because it's too far away. You just have to accept it on faith and believe it exists. Remember that the next time somebody challenges you for believing in creation, because it's religious and not scientific. The evolutionary model actually requires more faith than the creation model. Anyway, that's problem number 1 with the Oort cloud. Problem number 2 was just discovered recently. The evolutionary model says that comets originally formed in the TNO region, which is why we're talking about comets now in the TNO part of our tour. But the Oort cloud is supposedly much farther out than that, and surrounds the Sun in a huge sphere. How did all the comets get way out there? Evolutionists used to think that the comets migrated out there after they formed, but scientists have now realized this is impossible. It turns out that in the evolutionary model, there would be a lot of collisions along the way, and few comet nuclei would survive the trip. They'd be smashed into powder instead. So the Oort cloud, even if it did exist, would have far too few comet nuclei. It couldn't supply the comets that evolutionists need for their billions of years. Problem number 3 is that many comets couldn't have come from an Oort cloud. These comets are called short-period comets because they orbit the Sun in a short period of time, 200 years or less. Short-period comets don't last long. As I mentioned earlier, they can only go around the Sun a certain number of times before they're destroyed or leave the solar system completely. A maximum lifespan for a short-period comet has been estimated to be 10,000 years or less. Obviously, if the solar system was really billions of years old, we wouldn't see these comets anymore, unless there was a constant supply of new ones coming in to replace the old. However, a few years ago, evolutionists realized that the Oort cloud couldn't supply them. Short-period comets have certain orbital characteristics that make it impossible for them to have come from an Oort cloud, which is way out there in space. So, most evolutionists today also believe in something called the Kuiper belt. This would be a disk of comet nuclei orbiting out beyond Neptune in the TNO region that we've been talking about. Again, these have been sitting out there quietly for billions of years, but every once in a while, one of them gets disturbed, moves in closer to the Sun, and turns into a comet. Therefore, says the evolutionist, it's no problem that we still see short-period comets today. Yes, they only last for a few thousand years once they start orbiting closer to the Sun, but there's an endless supply waiting out beyond Neptune to keep replenishing them. Unfortunately for evolution, recent discoveries have shown the Kuiper belt model doesn't work any better than the Oort cloud did. First of all, NASA and other space agencies have been busy in the last few years studying comets. We've actually visited several comets with spacecraft. We sent the Deep Impact spacecraft to crash a probe into a comet called Tempel 1 to see what we could learn about the comet's structure. In an even more amazing feat, the Stardust spacecraft recently visited the Wild 2 comet. The probe actually flew through the comet's tail, collected material from it, and brought it back to Earth. Evolutionists were shocked when they examined this material. Remember, in the evolutionists' story, comets were formed in the outer reaches of the solar system. The evolutionary model says that things that formed way out there must contain certain elements and must not contain certain other elements. Well, we've discovered that comets aren't like this. The volatile materials that evolutionists expected to find in the comet's tail were either rare or non-existent. On the other hand, most of the material was made up of silicates that the evolutionary model says can't have been out there where comets were supposedly born. So in many ways, comets have turned out to be the direct opposite of what the evolutionary model predicted. But there's another problem too. The Hubble Space Telescope was recently used in a massive search for comet nuclei to confirm that they're actually there. The search was the biggest study that anybody had ever done of the TNO region, so far out there in space. Evolutionists expected to find about 85 comet nuclei in the region they searched. How many did they actually find? Only 3. This has massive implications. Even the scientists in charge of the project admitted that this is serious trouble for the overall idea of comet nuclei out there. These results mean that the number of comet nuclei is at least hundreds and possibly even thousands of times less than the number required for supplying short-period comets. The project's report said that the number of nuclei found was, quote, wildly inconsistent, unquote, with what evolutionists had expected. This means that evolutionists have no source for short-period comets. Therefore, they can't explain how we still see comets today after billions of years, even though these comets burn up after only thousands of years. Maybe it's because the solar system isn't really billions of years old. Here's what you aren't being told about comets and TNOs. The TNOs we see look young, not old. The comet material that we've sampled contradicts the evolutionary model. And comets shouldn't be here anymore if the solar system were really billions of years old. Comets are not only among the most beautiful objects in astronomy, they also reveal the utter bankruptcy of evolutionary models.